Hello student, let's try to understand preparation of alcohol student. There are many methods are there student for the preparation of alcohol. What we are going to do student, some of the methods we are going to follow. The first method is from acid catalyzed hydration of alkene. What is this student? When you are treating the alkene student, okay, with what you are going to treat student, you are treating with the water. Hydration means addition of water student, and in presence of the H2SO4 we have to take student dilute H2SO4, right student. So dilute H2SO4 will act as a catalyst student. So with the one carbon student, what is happening student, with the one carbon this hydrogen will go, and with other carbon it will go, OH will go. So here it will see student CH2 will become CH3, and this is CH2 and OH student. So this is what student, that the product form is, that is ethanol, right. 2 carbon is eth and OH group is all. Now student, if suppose you are having the compound, it is like that, unsymmetrical alkene, you are having CH3, this is CH student, and then it is what is there student, CH2, and you are treating with the HOH. HOH means I am writing the water student as a HOH. Now student, you are taking the H plus student, acid. What rule you are going to follow is student, because unsymmetrical alkene, this is follow the Marconi-Cops rule student, Marconi-Cops rule student. Marconi-Cops rule says student, negative part of reagent will adds to that double bonded carbon student which have less number of hydrogen. So OH will go where student, that is the second carbon, and hydrogen will go here. So what the product you are going to get student, it will be CH3 student, then it is the CH, here will be OH student, and this is again going to be CH3. So what is the product student? Prop, single bond in one all. This is what is the propanol student. Now if student, there is the some other methods are there. This was the first method which we have done student. Now we are going to understand from hydroboration oxidation. What reaction student? Hydroboration oxidation. Dear student, what we are going to do student, you are taking the unsymmetrical alkene or the symmetrical alkene student, and you are treating this with the what student, you are treating with the BH2 group student. Which group student? If you talk about, you are going to treat with the BH3 diborane student, you are going to treat with diborane student. So let me try to write student, this is the here is the diborane, here is student B2H6 is diborane, right. So we will use the BH3 student, BH3 multiply by 2, it will give B2H6, okay. So we are going to use the BH3 student, borane only. So here dear student, you see you are having the CH3, then you are having CH, double bond CH2, and if you are treating with the BH3 student, BH3, so what is going to happen student, one hydrogen is going to add here, and then BH2 will going to add here. So dear students, you will find the intermediate here, you see student, CH3, then it will become CH2, and it is going to add with the what student, again here is CH2 student. Why this is the size is very large student, here is again, here is the CH2 only student, this is the CH2, and here is BH2. This alkyl borane is there student. This alkyl borane is capable to react with another alkene molecule student, another alkyl. So how it is going to react with another alkene molecule student, if you can see here, okay. So let me resize this one student, that's okay, just I am putting the size here, okay, got it. So this hydrogen student, this hydrogen is going to attack on this position. Which position? On this position. So it will become the CH2. Now let us try to write again student, this is the CH3, CH2, again CH2, how many molecules student? 2, and here it become what student? BH. Now let us take the another molecule student. Which one? You are going to take another molecule. What the another molecule? Unsymmetrical alkene, that is prop 1 in student, right. So this one, which one student? This hydrogen is going to add this position. So what you are going to accept student, here is CH3, CH2, CH2, how many times student? 3 times, it is going to be B, right? Now student, what you are going to do student, you are going to treat with the hydrogen peroxide student, OH, and H2O2 we are writing, that is OH, right? So here you take the 3 molecule student. So when you are taking the 3 molecule student, so what will happen, it will give 3 molecule student, CH3, CH2, CH2, OH student, okay, 1 degree alcohol. This is what is student, 1 degree alcohol, plus what it will give student, BOH whole thrice student. This is, so this is what the product student. Now let us move, after the diborane we are going to another method student. What other method you can see student? From carbonyl compound, by reduction of carbonyl compound, by reduction of carbonyl compound. Student, carbonyl compound, what reducing agent you are going to use student? H2Ni student, right? Or you can use H2PT or H2PD, okay? Second one you will use student, LiAlH4 student. Third one student, you can use NaBH4 student. So these are the 4 reagent are there student that you need to use, okay? So any one of the reagent you can use, right? First one, suppose student you are having CH3 CHO, so you can use student any of the reagent you can use student, okay? That you need to keep in mind student, that you can use the any of the reagent. So I am using student, here is H2 and PD. So here it is going to hydrogen, this is going student. So here you see student, it is going to be CH3, here it will be that is CH2 and it will become OH student. So one hydrogen going to be C and one hydrogen is going to be O student. Suppose another alkene aldehyde you can take student, CH3 CH2 C double bond OH, and if you are adding the H2 student in presence of PD, so one hydrogen you send here student and another hydrogen you send here. So you see student, it is the CH3, this is CH2, CH2 and here is OH. This is again going to be 1 degree alcohol. Now student, if you can take the ketone student R, C double bond O and here are student, and either the reagent you can take in a student, same reagent you can take na, PT, PD or anything student. So here what will happen student, one hydrogen you send here, another hydrogen you send here. So what is the product you are going to get student? Here is R, this is CH, here is OH and here is R. So this is the 2 degree what is student? 2 degree alcohol student. So this is what is the product student. Now let us try to understand with the other reagent student. What I am doing here, I am taking some other compound student. Suppose I am taking CH3, this is C double bond O and here is CH3 student, and you are taking the with what student? LiAlH4. So one hydrogen you send here student, another hydrogen you send here. So you are going to get CH3, this is the CH, here is the OH and this is what student? CH3. So this is also 2 degree, what is there student? 2 degree alcohol student, right? Now from the carboxylic acid, so carboxylic acid is also having the similar group student, carbonyl group RC double bond O and OH. Student, you can take the LiAlH4 student, LiAlH4. So you can send the hydrogen here student, the bond is going to be breaked here student, okay? And here is some of the hydrogen you can send here student. So what you are going to get student? R, it will be CH2 student and this is going to form alcohol student, RCH2OH. But student, one thing you keep in mind student, this method is costly method. This is the costly method. So what you do student, what you do, firstly we convert the ester student. Suppose it is there RC double bond O and here is OH and you are treating with the alcohol student ROH, this one, and in presence of H plus student. What going to happen student, this is the going to be forming ester student. So here the product which you are going to get student, that is R, C double bond O, here is O and R. This compound is called ester student. Now ester is easily reduced with what student? H2NI student. So you take the 2 molecule of H2 student and you send some of the hydrogen here, some of the hydrogen here, and this bond is going to split here and some of the hydrogen here. So here you see student 2 type of alcohol you are going RCH2OH plus you are going to get student ROH, right student. So this is what the alcohol student, mixture of alcohol they are going to get student. This is the alcohol and it is also going to be alcohol student. Now the next method is what student? From Grignard reagent. From Grignard reagent. Okay student, from Grignard reagent. Student, if you talk about from Grignard reagent, so Grignard reagent you have to treat with the carbonyl compound student. So if you see student, if you see Grignard reagent plus formaldehyde student, formaldehyde, right student, formaldehyde, it will give student 1 degree alcohol. It is going to give student 1 degree alcohol. Now if you are having the Grignard reagent student plus other aldehyde, any other aldehyde, you are taking the other aldehyde student, it is going to give 2 degree alcohol student. It is going to give 2 degree alcohol. Now if you are having Grignard reagent student plus ketones, right student, ketones, so it will give student, it is going to give 3 degree alcohol, right, 3 degree alcohol. Of dear student, let's try to have the look over it. So here if you are having the RMgX, right, and here is the formaldehyde HC double bond O and this is H. So student, what you are going to do, this R is going to attack here, so this bond will shift here, so this will attract this one. So here you are going to get the intermediate student. What the intermediate student? H, C, H, and downside it is R student, and here is O, this is Mg and X student. Dear student, what you are going to do student, here you are treating with the HOH, right, HOH. This one is student, MgOHX, this is there, it is going to be out. So here student, you use this one, this is the MgOH and X is out, and you will find that is this R 1 and 2 and this hydrogen will go here, so it will be R, CH2 and OH student. So this is what student, this is the 1 degree alcohol, this is the 1 degree alcohol, right. Now student, you take the example, suppose you are having CH3MgBr, right, and you are treating with the H, C double bond O and H student. So let us see student, this group is attacking here, so this is coming attracting, accepting here, so it is going to give student CH3, upside you will get the CH2, here you are going OMgX. Now this reagent is going to hydrolyze student HOH, so MgOHX is out student. What is there? It is student MgOH and it is X plus what it is going to give student CH3, CH2 and OH student. This is the 1 degree alcohol student, right, 1 degree alcohol. Got it student. So now let us try to take the other example. Suppose you are teaching a student CH3 MgBr student, with what you are going to treat a student? Acetaldehyde you can take a student, CH3, C double bond O and H. So what you are going to get a student? You attack here student. If you are attacking here, so you are going to get the intermediate student CH3, this is C, here is CH3, this side there is H student, this side OMgBr, right, here is what student? HOH. Got it student. So this one is going to be out student, MgOHX, this is the MgOH and Br out student, plus what is left here? CH3, this H, here is CH3 and here is O and this hydrogen is going to be there student, that is H. So this is what student, this is the 2 degree alcohol, if you keep in mind 2 degree alcohol student, right. Now student, let us try to understand the next one. You are going to treat this with the ketone student. Suppose it is here student CH3MgBr student, and you are treating with the ketone. Here is CH3, C double bond O, and here is CH3. So what you are going to get is, student, this alkyl group is methyl group attacking here. So this bond is shifting on oxygen, and this oxygen lone pair electron will accept the magnesium. So dear student, here you see the what the compound you are going to get, CH3C. Here is the OMgBr, student. This side CH3, downside attack one, this is CH3. Student, you just put it the hydrolysis. Okay, just do it hydrolysis, student. So what you are going to get, student, MgOH Br is out, student. Here is MgOH and this is the Br is out, student. Now what is left, dear student? CH3 CH student, it is not the CH actually, this is the CH3. This will be what, student? It is not completely reduced. So student, CH3 C double CH3, here will be OH, student. This is the CH3, and downside if you see, student, this is also CH3. So this is what, student, degree of alcohol. This is the 3 degree alcohol, student, 3 degree alcohol. Now let us try to understand, student. Okay, these are the method of preparation of alcohol. These many methods are there, student, preparation of alcohol. One more methods is there, student, that I want to tell, from the alkyl halide, student, from alkyl halide. This is also there, student. So what you need to do, student, suppose you are having RX, just you treat with the NaOH, student. Okay, so it will give, student, ROH plus it will give the NaX will be out. This is the SN reaction, student, SN1 and SN2. Suppose, student, you are having the I am changing this one, student. I am taking this one, CH3 CH2, and what is there, student, Cl, and then I am treating with the NaOH, student. This is the SN reaction. So what is going to happen, student? This NaCl is out, student. So it is the CH3 CH2 OH plus NaCl. So this is the what, student? 1 degree alcohol, student. So this is what, student, our required answer. This is, got it, student? So thank you very much for watching, student. If you find this video helpful, please do like and subscribe the channel.